Okay, can everybody see my screen that says Chemistry 1401? All right, perfect. All right, well, let's get moving here. So Chemistry 1401, practice ACS final. Yes, you will always have a periodic table in chemistry. Always have a periodic table. We never expect you to memorize it. Okay, well, let's take a look at question number 1. But of course, we give you a periodic table that oftentimes doesn't have the name of the elements. Those are the ones that I prefer. It's not always what the university uses. But it's asking you to name this compound. So you have CrO3. Well, Cr is chromium, and chromium is a transition metal. And we know that the transition metals oftentimes can have more than one oxidation number. And oxygen, so is going to have an oxidation state of -2, and we have 3 of those. So that gives us an overall -6. That tells me that my chromium must be +6, right, in order to balance out the -6. So that would mean that this is chromium 6 oxide, right? This is the stock naming system where you use Roman numerals to indicate the oxidation number, or the oxidation number of the metal. Okay, so naming an ionic compound with a transition metal. Let's move on to question 2. What is the correct name of P2O5? This is a covalent compound. So covalent. Why? Because it's made from phosphorus and oxygen, which are both non-metals. They both lie to the right-hand side of the metalloid line. And so we use the prefixes. So we have 2 phosphorus, so we're going to use di, and then we have 5 oxygen, so we're going to use pent, right? So it's going to be diphosphorus pentoxide, right? It's not pentaoxide when the second element begins, or when the element begins with a vowel, we drop the at the end of penta, so it's pentoxide. Okay, let's try another question that involves nomenclature. It says here the formula for calcium hexachlorosilicate is CaSiCl6. What is the formula for boron hexachlorosilicate? Well, we need to figure out what the charge is on the hexachlorosilicate. All right, hexachlorosilicate is the SiCl6. How did I know that? Because I know that calcium is just the calcium atom by itself, right? Now I know that calcium has a charge of 2+ because it's in group 2A. It likes to lose 2 valence electrons to become isoelectronic with argon, the closest noble gas. And if the calcium is 2+, that would mean that the hexachlorosilicate is 2-. Now, what about boron? Boron is in group 3A. So it likes to drop 3 electrons to become isoelectronic with a noble gas, and therefore it's going to have a charge of 3+. So if I've got hexachlorosilicate with a 2- charge and boron with a 3+ charge, that means that I'm going to need 2 borons, and I'm going to need 3 hexachlorosilicates, SiCl6 3, right? Because +3 times 2 gives you +6, and -2 times 3 gives you -6, and we want those to balance out. So the correct answer is B2 hexachlorosilicate 3. So it's this one right here. Number 4, what is the formula for Bromis acid? Well, you should know bromic acid. So if you have HBrO3, this is called bromic acid. If you lose an oxygen, it becomes bromous acid. So that's the answer. HBrO2, which is right here. If you lose yet another oxygen, it becomes hypobromous acid. Hypobromous acid, and where I was going in my brain was to HBrO4, which is perbromic acid. Perbromic acid. All right, there we go. So the same thing applies for, chlorine and iodine. You'd have periodic, iodic, iodous, hypoiodous, so on and so forth. Anyhow, you need to know those. So just a little bit of acid nomenclature. Question number 5 says two students use the same standard mass of 1.0000 grams to calibrate the same balance by taking 3 readings. So we have Mike and Jean, and they're both taking 3 readings, and we want to compare the 2 sets of data, and the possible answers are shown down here. Mike's is accurate, Jean's is precise. Jean's is more precise and accurate. Mike's is both accurate and precise. Jean's is more accurate, but Mike's is more precise. Well, we need to define accuracy and precision first. So accuracy means closeness to actual value. And precision, the quickest definition I could come up with here would be agreement between measurements. Agreement or closeness between measurements. Okay. Well, if you look at Jean's data, you've got a 6 and a 4 and a 5 here. So hers is definitely the most precise. We know that. So the values are closest. So most precise, because you see that Mike's is all over the place. It goes all the way down from 0.9992 all the way up to 1.0000004. But in terms of their accuracy, the closeness to the actual value, you can see that Mike definitely comes the closest to 1.0000 grams. And so what I did is I took an average, right? So if you take the average, okay, Mike's average is 0.09998 and Jean's average is 0.9995. And so Mike is actually more accurate, right? He's not as precise, or his measurements aren't as precise, but overall he's more accurate. And so we would say that Mike is more accurate, but Jean is more precise. Okay, so that's just, having a little bit of knowledge of accuracy and precision. Question number 6, which element is represented by this? And I'll give you a second to look at it. Yeah, somebody said chromium, and up here we have the mass number, and here we have the atomic number, which is equal to the number of protons, and the number of protons governs the identity of the element. If you look at the periodic table, element number 24 is chromium. All right, well, next question says, what is the reading of this burette to the correct number of sig figs? I looked at this question last night. I was like, why did they leave that in there? She should have said, what's the correct reading? They told you it's a burette, but anyhow, I'll give you a second to think about it. If you look in the chat, I just posted the handout for the final exam. All right. So, I mean, this is pretty easy question the way it's put here because you always estimate one digit past the smallest calibration. So it goes 20. So this is 20.1, 20.2, 20.3, right? This is 20.5, right? So, and this is 20.4. So it's greater than 20.3, but it's less than 20.4. And you go, so 20.38, right? It's kind of looks what it looks like to me. All right, so you estimate one digit past the smallest calibration. All right, here we go. Number 8. How many protons? So how many protons, neutrons, and electrons are present in tin 2 plus 118? I'll give you a second. All right, well, tin, if you look on the periodic table, tin is element number 50. And so it must have 50 protons. Remember that mass number is the sum of protons and neutrons. So that means the number of neutrons is going to be 118 minus 50, which equals 68. And then for electrons, well, if I had tin with no charge, I'd have 50 electrons to balance out the 50 protons. But if I've got a 2 plus charge, that means I've lost 2 electrons. That would be 50 minus 2, which equals 48. So 50, 68, and 48. Is that one of the answers? Yeah, this one right here. 50 protons, 68 neutrons, and 48 electrons. Okay, next question. Which of the following are isoelectronic? I'll give you a second to look at it. All right, let's evaluate these. Let's start with aluminum 3 plus and phosphorus with a 3 minus charge. Aluminum has 13 electrons, so 3 plus, that means it's going to have 10 electrons. Phosphorus has a total of 15, so plus 3 is going to be 18 electrons. So 10, so those aren't isoelectronic. Bromine has 35, so that bromide would have 36 electrons. Selenium has 34, so selenium is not selenium with a charge, so that's 34 electrons. Neon and argon are definitely not isoelectronic. Neon has 10 electrons and argon has 18 electrons. Okay, but if I look at fluoride, fluorine has 9. Fluoride is going to have 1 more, so that's 10. Magnesium has 12. Magnesium 2 plus is going to be 10 minus or 12 minus 2, which gives you 10. So the answer is fluoride and magnesium 2 plus. Those are isoelectronic. All right, remember, Joel, the selenium doesn't have a charge. So it doesn't have the same number of electrons as bromide. Okay, let's see here. Let's move on. Number 10, I'll give you guys a second to give this one the old college try. Balancing the equation. All right, some people are saying 2. Well, if we have calcium, we have calcium sulfide plus oxygen gives you calcium oxide, dioxide. Remember, the trick is any element that's by itself, always save that for last. So look, I have one calcium, good, one sulfur, good. I have 2 oxygens here, and here I have a total of 3 oxygens, so that means I would multiply this by 3 over 2, right? 2 times 3 over 2 gives me 3, but that's not a whole number, is it? So that means I would want to multiply this whole thing by 2. So times 2, which would give me, let me just delete all that. That would give me, there we go. That would give me 2, 3, 2, and 2, like that. And so the coefficient in front of my calcium oxide is 2. Thanks. Great. Awesome. Let's try with equation. What is the maximum number of carbon dioxide molecules produced if 0.48 moles of butane combusts in the presence of oxygen? Well, this one here, this is butane, C4H10. We've got 0.48 moles of C4H10. And from our balanced equation, we can see that for every 2 moles of C4H10 that are consumed or burned up or combusted, we produce 8 moles of CO2. Okay, now we're looking for the number of molecules of CO2, and we know that in 1 mole of CO2, we have 6.0210, right? We have Avogadro's number of molecules of CO2. And when we multiply all that spinach out in our calculator, I ended up with 1.2 times 10 to the power of 24 molecules. There you have it, folks. Okay. A sodium atom differs from a sodium ion. Well, this one, a sodium ion, so a sodium ion is Na+, right? Because sodium is in group 1A, it will lose 1 electron to become isoelectronic with neon. A sodium atom is simply sodium with 1 valence electron. A sodium ion has fewer electrons. Is an isotope? Well, it's definitely not an isotope. They both have the same number of protons. Has a negative charge? No. Sodium has a positive charge. It exists only in solution? Not necessarily. We have a sodium lattice phase. We looked at lattice energy enough times, but sodium plus has 1 fewer electron, doesn't it? It's lost an electron. That's just a conceptual question. All right. Okay, question number 13 says element X occurs naturally to the extent of 20% for isotope 12 and 80% for isotope 13. The atomic masses, well, remember the atomic masses that you see on the periodic table are weighted averages of the isotopes. And since we have the percent weight of each isotope, we'll just take 12. So if we have 12 AMU for the first isotope, and that's 20%, so that's 0.200. I'm just dividing 20 by 100. That gives me 2.4 AMU. And then if I take the weighting for the isotope with an atomic mass of 13 times 0.800, that gives me 10.4 AMU. And then I can tally those two up to get the weighted average, and it would give me 12.8 AMU. All right, which is right there. Number 14. What is the valence electron configuration for the element in period 5, group 3A? So if I look at period 5, I start with rubidium, strontium, then I cross the transition metals. And then when I get to group 3A in the 5th period, I have indium, element number 49. So indium, like that. So it's asking me for the valence electron configuration. So I have krypton, which is the noble gas that precedes indium. And then I'm going to have 5s2, 4d10, and then I'm going to have 5p1. And so the valence electrons, those are the ones with the highest principal quantum number. And so it would just be 5s2, 5p1. Is that in here? Yep, right there. All right. So valence electron configuration. Number 15. Which species has this ground state electron configuration? So 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. So normally we think about it as going 3. We think about electron configuration as going 3p. Son of a bitch. Pardon my language. Sorry. 1s2. Hope you'll forgive me. 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d10, right? But then we have the first in and the first out rule, right? So if we have that ground state electron configuration, it's asking us what species, not what atom. So this is going to be an ion. So what's going to lose, or what's going to have this many electrons, right? If you had only if you had lost these 2 electrons, right? If you tally up the total of electrons here, you have 30 electrons. So when you lose 2, lose 2 electrons, then you've got you're going to have 28 electrons, right? So 30 electrons is element number 30. That would be zinc, right? And if I lose 2 electrons, then it becomes zinc with a 2+ charge. And so the answer is zinc with a 2+ charge. Give me a thumbs up if you follow me on that one. All right.